Today's lesson topic is solving one-step equations. If you'll go ahead and update your table of contents in your Math Interactive Notebook to today's lesson topic, make sure you have the correct date, whether it be December the 3rd, 4th, or 5th, depending on the day that you are at this station, and make sure that you have your page number updated as well. I will be beginning today's lesson on solving one-step equations on page 56 in my interactive notebook. Once you have your title at the top of your page, at your station you'll notice several handouts. One of the handouts looks like this one in front of you. Okay, if you'll go ahead with that handout and take and trim along the outside edge of that handout with your scissors, right around the perimeter, making sure to not cut anything off or from your handout other than the excess space around the perimeter. Once you have it cut out where it looks like this, you're going to take your scissors and cut along this bolded line and cut this top portion, about a third or so, right off of there. And this portion right here, you'll notice on the left side and the right side has some dashed lines. You'll take and just use your scissors along those dashed lines and cut right up to the bold section so that you have two flaps like so. And turn it around along the other dash line and use your scissors to make some flaps like so. Set that to the side for just a moment and go back to this piece that you tore off or cut off. Right along this line here, I want you to take and turn it upside down and fold back to that line just like this. Using your glue stick, you're going to take and put a little bit of glue, being careful not to get any over on this part, okay, just on this small skinny piece here. We want to take our glue stick and put a little just like that, and then turn it like this, upside down, or right side up rather. Put it right underneath your heading at the top of your journal page. This way it lifts up like a flap. That's why you want to make sure no glue was on this portion. Once you've done that, if you'll take the other piece, fold your flaps in like so. Okay, so you've covered everything up. Turn it over face down. Put you some glue all over the back of that. Okay, and go ahead and place that right in your journal on your page, just right like that. Okay, once you've done that, you're finished with your glue stick and your scissors. Okay, so we're ready to learn today. All right, so our goal today would be to solve one-step equations, and we've already seen this in class. We've practiced some with this, but this is a nice reminder of using our inverse operations and our properties of equality. Okay, so underneath your flap here, I'd like you to put what our goal is for today's lesson. Our goal for today's lesson is to be able to not only solve one-step equations, but we're going to learn how to isolate the variable. We talked earlier last week about what it means to isolate something, and in this case, isolating the variable means to get the variable on one side of the equal sign in an equation and a given value on the other side so that you can determine how much that variable is worth. Okay, so we are going to look at this first top left flap here first. If you'll go ahead on the outside of that flap and label that flap as addition. Okay, you can open your flap up. And what is the inverse operation of addition? The inverse is the opposite operation, so you probably said aloud, subtraction is the inverse operation. So right now, if we look at this equation, x plus 4 equals 7, we know that x is our variable. It's a letter that stands in place of a number in this equation. We don't know what x is at the moment, but we know how to get x by itself, and that is to undo what is being done to x. So right now x has 4 that's being added to it. So what we want to do is we want to do the opposite, or the inverse operation of what's being done. So the opposite of addition, the inverse, is subtraction. So we want to take away what's being given to x. So x is having 4 added. We want to take 4 away. And using our subtraction property of equality, in an equation, we have to subtract the same thing from both sides of our equal sign so that our equation stays balanced. When I add 4 to x and then I take 4 away, that cancels out like a zero pair and leaves x all by itself on one side of the equal sign and 7 minus 4 on the other side. 7 minus 4 is 3, so I've determined that the value of x and the solution to this equation is 3. I can substitute 3 in place of my variable in this equation. 3 plus 4 equals 7. Add my like terms here on the left side. 3 plus 4 is 7. You can see that my values on both sides of the equal sign are the same, so x equals 3 is a solution to the equation. We were able to determine that by subtracting the same value from both sides of the equation. That is the subtraction property of equality. Go ahead and label that subtraction property of equality. Take a highlighter or a marker or your pencil and underline subtraction property of equality there. Okay, the next flap that we're going to look at is our next equation. This flap is going to be our subtraction equation. So on the outside, if you will label that flap subtraction. And I need you to be thinking about what the inverse or the opposite operation of subtraction is. Well, you may be looking at this and say, oh, well, that's addition. Well, let's talk about this equation for just a second. Before we get to that, the inverse operation for subtraction, you're probably saying, is addition. So I'll go ahead and put my addition sign here. Okay, so if our goal is to be able to isolate the variable in order to solve one-step equations, okay, x is being added with negative 2. Negative 2 plus x. So our goal is to do the opposite of what's being done to x. Right now, negative 2 is being added to x. So the opposite or the inverse operation of subtraction is addition. So what do I need to do in order to solve this problem? Well, if negative 2 is being added to x, I need to take or subtract negative 2 away. Remember from last week, subtraction is the same as adding the opposite. So if I subtract, which is the opposite of addition, if I subtract negative 2, that's the same as adding the opposite of negative 2 is 2. Okay, so taking away negative 2 from both sides is the same as adding 2 to both sides. Subtraction is the same as adding the opposite. When I do that, these cancel out, negative 2 and positive 2 cancel out, which leaves me with just my variable x, and x being equal to 12 plus 2, which is 14. I can substitute that back into my equation. Negative 2 plus 14 equals 12. If this is a scoreboard, plus and negative, 14 points for the positive team, 2 points for the negative team. The positive team has more points, and they have a difference of 12 points. Okay, or they won by 12 points. So this x is a solution to the equation when it equals 14. This is the addition property of equality. If you'll label that addition property of equality. Okay, let's look at our bottom left flap. It's going to be our multiplication flap. So the inverse operation of multiplication is division. So in order to isolate the variable here, 24 equals negative 8 times x. In order to isolate that variable, we have to undo what's being done. Currently, negative 8 is being multiplied by x. So to undo that, we need to divide both sides of the equation by negative 8. Negative 8 divided by negative 8 gives me positive 1. And so that just leaves me with x all by itself over here. Those cancel out. And 24 divided by 8 is 3. A positive divided by a negative is a negative. So x is equal to negative 3. I could substitute that back into my equation. 24 equals negative 8 times negative 3. Well, 8 times 3 is 24. Negative times negative is positive. So my equation is balanced when x is equal to negative 3. This is the division property of equality. Okay. Our last flap that we're going to look at is our division flap. Okay, the inverse of division is multiplication. Okay, and in this case, x divided by 6 equals 5. So the opposite of dividing is multiplying. So instead of dividing both sides by 6 now, we need to multiply both sides by 6. If we multiply something by 6 and then divide it by 6, guess what? It cancels out. So we're left with x equals 5 times 6, which is 30. We did the opposite operation. So substitute 30 in place of x back in our equation. 30 divided by 6 equals 5. 30 divided by 6 is 5. 5 is equal to 5. That is a solution to the equation. This is the multiplication property of equality. Okay, what you're going to do now is at your tables you have a handout that looks like this. It has some one-step equations on there. You're going to use your foldable in your notes here, okay, to work through each one of these 8 equations, isolating the variable and solving for the unknown by performing the inverse operation. So in number 1, x minus 7 equals 22. The operation right now is subtraction. So we need to do the opposite of that. We need to add 7 to both sides of the equation using the addition property of equality. That's going to eliminate the 7's on the left side and leave us with the value of x. Plugging that back into my equation and checking to make sure that what I came up with as the value of x is a solution to the equation. Once you've used your foldable as an example and worked through all 8 of these problems, you're going to fold this almost in half and attach it in your journal on the next page. You can get a piece of tape from the bin and just attach it in your journal. If you finish all of those before time, you have another handout at your station that looks like this. Okay, you're going to separate the word problems from the parallelograms on the right, and the instructions are at the top. You're going to match and paste the variable description from each word problem and the equation that matches each word problem, and then solve. Rewriting the equation, solving for the unknown, and then writing the solution in a sentence, what x is equal to. You have about 5 minutes or so left at this station, most likely, so go ahead now as a group and begin solving the one-step equations and then moving on to the word problems. Put these in your station folder if you run out of time.